Hello everyone, here are some questions about momentum. I'm gonna also post annotated versions of these notes. We solved many similar problems, but these will be some extra if you want to have a look at them. In assembling a train from several railroad cars, two of the cars with masses 2 times 10 to 4 kilogram and 4 times 10 to 4 kilogram are rolled towards each other. So this is before picture, and in the before picture I already drawn for us. We have P initial, and that's a vector again. It's equal to P1 initial plus P2 initial. And we know masses, and we know also velocity of the first car, but the other car we don't know the velocity. And the after picture here, it says the lighter car has an initial speed of 1.5 meters per second. The collision causes it the reverse direction at 0.25 meters per second. What was the initial speed of the heavier car? We know the initial speed is to the left. It's going to be negative. After the car 2, car 1 has positive, and after the collision they both have a negative speed. We can go two-way here. Either we don't define the direction of the unknown, and algebra will give us if it's plus or minus at the end, or we define the direction, but the value we will find at the end will be the magnitude and not the direction included. Let's look at the P initial here. P initial will be M1 V1 initial plus M2 V2 initial. I'm going to define the directions here, and the value V2 initial we find will be the magnitude, and direction is negative, we just know that. If I leave this guy as positive again, I can also go that way, and the result will give me the result direction as well as negative, but this only works if we have a 1D case. So I'm not going to go that way. I'm going to put the direction, and I'm going to find the magnitude. So that's P initial, and P final from the after picture here, that's the after picture, is equal to M1 plus M2 we final together. We're still in vector form. As we move into the magnitude form, we're going to put in direction. We'll say P initial is equal to M1 V1 initial minus M2 V2 initial, because V2 initial is negative, V1 initial is positive, and the magnitude of P final will be negative, so minus M1 plus M2 V final. And we know P initial is equal to P final, momentum is conserved, and we'll equate them. M1 V1 initial minus M2 V2 initial equals minus M1 plus M2 V final. Rearranging, I would just take this guy to the other side as positive, this guy to this side as positive. Keep in mind I'm going to get a positive value for V2 initial here because I'm only calculating magnitude, but I know it's negative. If I ask you the direction, it would be clearly said is to the right or to the left, or V2 is this much negative. But I would generally ask you the magnitude if it's obvious already that it's negative. You guys don't need to include it in here. So here's what I'm going to have when I do that switch. I'm going to have this rearrange, and I'm going to have M2 V2 initial is equal to M1 V1 initial plus M1 plus M2 V final, and dividing each side by M2 will give me V2 initial. M1 V1 initial plus M1 plus M2 V final divided by M2. Put in all those numbers that are given in the pictures. You'll find the velocity as 1.125 meters per second. Please go ahead and solve. I am using this approach of solving for what I'm looking for algebraically first, without putting any numbers, then putting in numbers. I notice many of you like going this way. You find P initial, M1 V1 initial, plus M2 V2 initial. You know this guy is negative. You put that in, you put in all the numbers. That's all fine. M1 is 2 times 10 to 4. You guys don't put in any units. You don't have to. Keep SI units and the result will come out right. Minus 4 times 10 to 4. You don't know V2 initial. Then you find P final as a number. It's minus M1 plus M2 times V final. That will be minus, when I add the mass, is 6 times 10 to 4 times 0.25. You guys find this as a number, insert it in here. This actual will be 3 times 10 to 4, and then you work out with the numbers, which is the same thing. Whichever way you feel comfortable, go that way. Then you say P initial is equal to P final. Put in everything as numbers and work out your solution. That's also fine. Whichever way you feel more comfortable, go that way. No problem there. This one is also a very similar question. We have two objects colliding here. They're not sticking together in this case. They're going in different directions. So the question says two balls with masses M1 2 kilogram, M2 10 kilogram. Let's put them on the picture here. We have a nice picture here, so we don't have to draw an ugly picture of ours. M1 is 2 kilogram, M2 is 10 kilogram. And keep reading now. Collides elastically as shown in the figure if the velocities after the collision are minus 3.33, which would be this value here, minus 3.33 meters per second. Notice here I'm not putting minus because it's shown in the direction already. And V2 final is 1.67 meters per second. What is the initial value? Initial velocity of M1. M2 is stationary. So this is before picture, right? They said already before collision. We have before, we have after pictures. And momentum before is always equal to momentum after. Or momentum initial is equal to momentum final. Right, the same as P initial is equal to P final. And we're going to write down P1 initial plus P2 initial is equal to P1 final plus P2 final here. And we're going to put in the values. Let's put in the vector signs now. We didn't put any directions yet. We're going to input the values with the directions. So this guy will be negative here. This guy will be positive, positive. So P1 initial, M1, V1 initial equals to minus M1. V1 final, that negative value here, plus M2, V2 final. And I'm looking for this guy, so I'm just going to go ahead and divide. V1 initial is equal to, if I divide both sides by M1, I'll get my answer. So that's actually easier than the previous question. So I set in my values, and all I have to do now is input the numbers, right? I'll have V1 initial is equal to minus M1 2 kilogram. It should be V1 final. V1 final is 3.33 meters per second. Notice this negativity is coming from the negative velocity we have here. If velocity is negative, momentum is negative. So we put the negative sign over here. Plus M2 is 10 kilogram. And V2 final is 1.67 meters per second. And we divide all that by 2, the mass of the first ball, 2 kilogram. And we'll get a value of 5.02 here, meters per second. And we already know it's to the right, positive. Again, we'll calculate the magnitude after we put in all the directions as plus and minus. The value we get is magnitude. And we decide the direction as using our logic. Explosions are also different kinds of momentum conservation. Only initially we always have zero momentum, then the stuff explodes. We should have still zero momentum. We use that idea. This is a nice example here, actually showing initial momentum is equal to final momentum, or P after is equal to P before. To solve for a velocity of an unknown piece, we did a similar question in class. Review this as well. This one is the type of collision. We have a rifle here, a toy rifle. Initial momentum would be 0. This is also in the book. Final momentum should also be 0. We have before and after pictures. And all similar ideas then here. That's why we have recoil. We push the ball out from this toy rifle and it will be pushed back because initial momentum was 0. So the system wants its final momentum to be 0 as well. All we have to do here is collisions are easier actually. We'll say P initial is equal to P final. So final momentum should also be 0. Again, keeping in mind their vectors. So if I have momentum to the right of this much, I should have equal of that to the left because I want 0. It's like similar to right forces are equal to left forces. In this simple case only, we can say right momentum should be equal to left momentums. We'll just write down what we have. We have plus here, minus there. If the momentum is 0, we'll just say M1 V1 final minus M2 V2 final equals 0. Right, this is the rifle's recoil. I called that V2 final. To simplify it, I call this V1 final. And the ball, they have their masses M1 and M2. We'll put those and solve for what is asked for us, V2 final. And if I rearrange this, I would take this guy to the other side as positive. I'll have M1 V1 final equals M2 V2 final. I get to the result algebraically that I already thought about physically. Right momentum should cancel left momentum, right? So they should be equal. If I know that total momentum is 0 in this case, I can safely say that. But I should be careful. Again, we have 2D cases, different cases. It's not always this simple. And I'm looking for V2 final. I'm going to divide each side by M2. So I'm going to say V2 final equals M1 V1 final divided by M2. Putting in all the numbers here, given they're also on the pictures. Again, I call the rifle here M2 and the mass of the bullet M1, and we want to finalize this value here. So M1 is 0.03 kilogram. V1 final is 15 meters per second, and that divided by M2, which is the rifle's mass, 1.2 kilograms. And if you put in all those numbers and do the calculation, you'll find the velocity of the recoil of rifle to be 0.38. Again, I'm calculating this as magnitude, but I know I already figured out from logic that it's negative. In 2 dimensions, there isn't much different other than having x and y momentums conserved. General idea is we calculate all initial x momentum, add them, we say they are equal to final x momentum, and do the same for y. As we do this, we want to mind plus and minus directions. Take right to plus, right as plus, left as minus. So stick with regular approach. Along x, right is plus, left is minus, and up is plus, down is minus along y. There's no different direction that would make our work easier, so we'll just go with general convention. Here we said, and we'll do that. This one would be one hardest question. If I want to give you a hard time, I would ask a question of this sort. But idea is again one px initial equals px final and py initial equals py final. You want to find all those, find initial momentum, and then combining them, say p initial, get p initial, and you say this is equal to p final. So let's read this question here. This question says there's a falcon often grabbed the airplane in flight. A falcon flying at 18 meters per second. I'm going to read the raw. They have a picture for us, but it's hard to work on there, so I'm going to draw it. It's flying at 18 meters per second, swoops down at 45-degree angle. So for falcon, this will be its initial velocity. I'm going to call this person 1 here, falcon. So it will have m1, v1, and so on. And I'm going to call what it is catching. It's a pigeon, m2 and v2 and so on. So keep that in mind. Instead of using falcon and pigeon, we'll use m1 and m2. So this is v1 initial then. v1 initial, 18 meters per second. And it has swoops down at 45-degree angle, means, well, these two angles are 45 degrees. Actually, I'm going to delete this right, and then I'm going to show the angle there. Okay, if my computer lets me delete, I'll delete. Alright. And so this angle is 45. And this is v1 initial. If this is v1 initial, p1 initial will be in the same direction, right? So what I can do is find p1 initial, m1 v1 initial. And that will be along this direction. So I'm going to show that in red maybe here. Because I'm going to go with momentum. So if I know my velocity. Let me try that again. P1 initial will be exactly in the same direction, but mass times the velocity. So I show that. And let's keep reading now. This will be my before picture. The Falcon has a mass of 0.8 kilogram. Let's put this in here. This will be my M1. 0.8 kilogram. I know we want initial 18 meters per second, 45-degree angle, I showed that. And he catches a flying pigeon that flies at 9 meters per second. And the pigeon has a mass of 0.36 kilograms, so M2 is 0.36. And V2 initial is 9 meters per second. The picture shows it that the pigeon is flying only along X towards negative X direction. So in here, initial, actually I should also show the direction of pigeon's velocity, right? So let me delete this before here. So that was for my M1. My M2 has this velocity. This is V2 initial, only along X to the left. And P2 initial will also be to the left, right? And it will be equal to M2 V2 initial. So here are their masses, kilogram. Let's leave that out. 3.36 kilogram. I'll put it over here. What are the speed and direction of the Falcon immediately after impact? So again, this is before picture. And we're looking for after picture. The pigeon will, Falcon will catch the pigeon and they will go exactly at the same momentum right after. So idea is P initial is equal P final. We're going to find P initial, and we're going to say P final is exactly equal to that in magnitude and direction, and solve for the speed and direction using M total V final. So let's look at P initial here. We have components, so we're going to look at Px initial. Px initial is equal to Px1 initial plus Px2 initial. That's it, we have two objects here. Px1 initial is equal to P initial cosine 45, and Px2 initial is just P initial 2, P1 initial here, sorry, and P2 initial, because P2 initial is just along X, right? And both have components in negative directions. So one is only along X, negative direction. Px initial will be this guy over here. P1x initial, sorry. And P1y initial will be down. And P2x initial is just P2. There's no y component, so P2 y initial is 0. Now we're going to put in values and calculate these. They're both in negative direction. We showed them in here. We'll just look at the magnitudes. And we'll say Px initial is equal to M1 V1 initial cosine 45 plus P2 initial. Not P2 initial, let's put M2 V2 initial here. M2 V2 initial. When we put in all the numbers and calculate the initial X component of the momentum, I'll leave it up to you to do, folks. All the numbers are in here. We will get an X component of 13.42 kilogram meters per second. Momentum, X momentum. Y momentum will be easy. Let me go back to blue here. Py initial is equal, let's not forget the vector sign here, py1 initial plus py2 initial. Directions are important. That will be p1 initial sine 45 plus 0 because p2y initial is 0. So simply just y component of p1 initial. m1 v1 initial sine 45. Put in all the numbers, you'll get your py initial as 10.18 meters per second. And y is down, only x is left, so I'm going to draw a symbolic show of this. So here is our px initial. That's equal to, we found to be 13.42 kilogram meters per second. This is our vy initial smaller, sorry, py initial 10.18 meters per second. What do we do after this is to find the initial momentum. And if we find the initial total momentum, we also have the final, because we know initial is equal to final. I'm going to use straight line here to draw a better picture. So this is our P initial. How do we find this? Is Pythagorean. And the angle we can define as from x-axis always using tangent. Alright, so P initial now equals square root of px initial squared plus py initial squared. Put in the numbers, you'll find that to be, let me see if I have it somewhere here, 16.84 kilogram meters per second. Direction alpha is, as always, tangent to -1, y component over x component, so py initial over px initial. And that will give you an angle of about 37 degrees. Now, almost done. I'm asked to find the final velocity. If I know the final momentum, velocity is in the same direction. By the way, the final momentum would be exactly the same, right? Initial momentum is equal to final momentum. So I'm going to draw that here as well. That's the final. Exactly the same direction, same magnitude. Let's write that again. Alright, so P final is exactly equal to P initial. And all I have to do now is go ahead and say, find the magnitude of velocity using P final is equal to m1 plus m2, V final. So V final will be equal to final momentum divided by the masses added, and that will give you your value of final velocity, which should be about 14.52 meters per second. Again, this would be by far the hardest question if you're asked it. If I really want to give you a hard time, I would ask you this question. This one is a nice cute question here. We have two objects, 1 and 2, in this direction with these initial velocities. They collide, they stick with each other. After the collision, what is the angle theta? And what is the velocity of the combined objects? Similar question. Idea is similar, but this one is a lot easier, because we only have x for one momentum and y for the other. So we'll do the same. P initial is equal to P final here. And we'll find Px initial, P1x initial, plus P2x initial. And we will say that 2 does not have any x component. This will be 0. So Px initial will be simply P1x initial. And it's only along x. So that's simply M1 V1 initial or V1x initial. But it's only along x. And similarly, Py initial will be only P2y initial because P1y initial is 0. So set that to 0. M2 V2y initial. Don't forget the vectors here. I can draw my vectors. This is Px initial and this is Py initial. If I carry them to one point and draw them, here's what I'm going to have. And you guys want to do this, carry them to one point so you can see what is your total momentum. The total momentum should be in this direction here. Initial momentum. Well, initial is equal to final. So final will be equal to initial. We'll say, well, this is P initial. And it's equal to P final, right? So I can find that P initial using, I can also show that in here. This is my P final. It's equal to P initial. In magnitude, it's equal to Px initial squared plus Py initial squared, right? You'll find that all the values are given. Let me put them in here. Two objects with the same mass, so they have the same mass. M1 is equal to 2 kilograms, M2 is equal to 2 kilograms. Collide and stick with each other after collision as shown in figure down. If the initial velocities were 10 and 10, so both have the same initial velocity, this is pretty easy then. And same velocity here. What is the angle theta and the velocity of combined objects after the collision? So you find those values. Px initial, M1 V1 initial, and Py initial is M2 V2 initial. That's it. Put them in here, you'll find a P initial, which is equal to P final value as, let's see if I have that here, 28.28, so about 28.3 kilogram meters per second. Angle theta, as always, tangent to -1, y component, Py initial over Px initial. They'll give you 45 degree in this case. Not 40, 45. We can also guess that they have same initial momentum, different directions. When they add, they will be having the same components. That always gives us 45, but you don't have to guess that, of course. I'm gonna rewrite this 45 here. Okay, now I have the momentum. I'm asked to find the velocity. That's easy. P final will be equal to M1 plus M2 V final, and I'll solve for it. V final, when I divide both sides by M1 plus M2, will be alone, so I'll have P final over M1 plus M2. And when you put in the numbers, you'll get a velocity of 7.07 meters per second. And that's it for the momentum.